Hello and Namaste. After the detailed discussion on the different problems on the Z transform, we are starting with the inverse Z transform with the introduction and the different problems based on the Z transforms. Now, what is this inverse Z transform means? Finding the sequence f of k, or sometimes it is also, I'll be taking, as I've told you before also, it's like f of n also, from f of z is defined as inverse Z transform. It is denoted as Z inverse of capital F of Z, which is equals to sequence f of k. Z inverse is the inverse of inverse Z transform. So Z inverse is nothing but the notation used for the inverse Z transform. The first question is find the inverse Z transform of 1 upon Z minus 2 under the case 1 mod of 2 by Z is less than 1. Now, if this is f of z is 1 upon z minus 2 and we have the region as mod of z upon mod of 2 by z is less than 1, that means we have to arrange this particular. So if you'll observe here, we have got it here z in the denominator, 2 in the numerator. So that means we have to have this particular function. We can have to have, this is nothing but divide and multiply, 1 upon divide and multiply the denominator with z. So it is nothing but like this, and then this particular z will remain here, this particular z will remain as it is over here, 1 by z, and the another z, this will go in the denominator, so inside the square bracket. So that will gives us z by z minus 2 by z. That would gives us this step, or you can check it 1 by z into 1 upon 1 minus 2 by z. This is what we wanted to have it, because we have been given here mod of 2 by z. So we should have this particular function into the picture over here. Then only it is easy for us to understand. So if you observe here, this is what 2 by z has come into the picture. So f of z is 1 by z into, now this 2 by z can be written as 1 minus 2 z to the power minus 1. This can be written as, so this is nothing but z to the power 1 minus 1, which is this 1 by z can be written as z to the power minus 1. This bracket, this entire bracket can be taken in the numerator with raised to minus 1 as, and if you observe here z to the power minus 1, and if you observe 1 minus x to the power minus 1, which is nothing but 1 plus x square plus x cube. This is what is the series which we have already seen in the previous section of Z transform. The same series we are going to use it here. So this is nothing but 1 plus 2z to the power minus 1, 2 square z to the power minus 2, and so on. And if you observe here, this is nothing but if we will multiply this entire square bracket with z to the power minus 1, we'll be getting over here like this. And therefore, if you'll observe here, in this case, Z inverse is nothing but to find out or to identify the z to the power minus k, the coefficient of z to the power minus k, we have to have it here. So if you observe here, in the case, first case, z to the power minus 1, 2 into z to the power minus 2, 2 square into z to the power minus 3, and in this way, if you observe here, we'll be having this 2 to the power k minus 1 into z to the power minus k. If you'll observe here, we'll be having, and that's the reason the inverse Z transform of this particular function is nothing but 2 to the power k minus 1, k is greater than or equals to 0, which is nothing but the coefficient of this particular z to the power minus k is nothing but the Z inverse of this particular function at this in this particular ROC or region. Looking at the case 2, if mod of z by 2 is less than 1, so what we have to do it here, this is the function given to us, and we have to have, because it's a z by 2, we have to divide and multiply. So if you observe here, this is nothing but 2 by 2 of the function z minus 2. This can be written as 1 by 2 as it is into 1 upon z by 2 minus 1, and this can be written as over here. But again, because we need it here always 1 minus x, so that's the reason we have taken here minus sign outside. So we have written minus 1 by 2 into 1 upon 1 minus z by 2. This is nothing but in this way, the same way what we have done it here. We have taken that in the numerator. Again, this is minus 1 by 2 into 1 minus z by 2 the minus 1, and therefore this is nothing but minus 1 by 2 into this expansion will give us, this is what is the expansion of 1 minus x to the power minus 1, that is 1 plus x square and so on till the infinity. This is what we have expanded over here. After this expansion, if you will observe here, the coefficient of z to the power minus k. How to find out the z to the power minus k over here? So we can easily check this out, which is nothing but minus 2 to the power k minus 1, k is less than equals to 0 in this particular case over here. And note, very important is, the inverse set transform can only be settled when the region of convergence ROC has been given, and that's the reason we have considered here two different ROCs. Mod of 2 by z is less than 1 and mod of z by 2 is less than 1. Moving ahead with the next question, find the inverse Z transform of 4z upon z minus a for this particular two regions. One is greater than, one is, another is less than region. If you observe, this is mod of z is greater than a, that means this 4z upon z minus a, which is 4z upon z, as what we have done it in the last case as well, we have to do it with the same here. So if you'll observe here, we wanted to use that 1 minus x the power minus 1 expansion only if we have got the mod of this x is less than 1. Same thing we have to have it here over here. So it's mod of z is greater than a, that means what? Mod of z is, or otherwise you can check it here, mod of a is less than mod of z. That means mod of a by z is less than 1. That means here we have to have it here a by z form. We have to bring it up a by z form, what we have done in the last case, the same way here also, and then just the expansion, then expand it very well, and then you will understand it. The z to the power minus k, the coefficient of this z to the power minus k is 4 into a to the power k. You can easily check it here, 4 into a to the power 0, 4 into a to the power 1, 4 into a to the power 2, 4 into a to the power 3 and so on. Similarly, we can have it 4 into a to the power k, z to the power minus k, which is nothing but this, and hence the z inverse of 4z upon z minus a is equals to 4a to the power k, but this is a sequence. This is not a single term. We have to write down this in the curly bracket, and this is for the case 1, mod of z is greater than mod of a. Similarly, for the case 2, mod of z is less than mod of a, that means it is nothing but z upon a is less than 1. If you observe here, the same way here, but here we have to divide and multiply the denominator with a, and that is what we have done it here. I'll just scroll fast because this is almost the same what we have discussed so far. So just pause the video, try to get the series and try to get this answer on your own. This is what is 4 into minus z by a minus z square upon a square and so on. And if you observe here, what the series we are going to get it over here is nothing but this is minus 4 upon a to the power 4 minus 4 upon a cube minus 4 upon a square, and this is what is nothing but minus 4 upon a to the power k as the sequence or the particular sequence or the inverse z transform of the function we are going to get. I hope you have understood the inverse z transform in a nutshell, but yes, we are going to go ahead with the different methods of finding out the z transform in the upcoming session. Stay tuned, stay connected. Thank you. Happy learning.